Alright, so I said I was going to come back to that idea of the divergence being zero, and that idea of the divergence being zero, we think of the vector field as being incompressible. That's the language that we use. Okay, just a vocab term, okay, and so again, that captures the idea that the infinitesimal net flow is zero. Okay, alright, and then something, or I guess an example of where incompressible pops up is that when we look at a vector field, at least in R3, and it's continuously twice differentiable, then if we look at the del operator dotted with the del operator cross F, okay, so again, that's zero. So what we're thinking of is if we look at, this is in here, right, that's the curl. And then if we do the divergence of the curl, right? Okay, so then the whole thing is the divergence. So the divergence of the curl is zero. Bonus question, can you do the curl of the divergence? I'll let you think about that one. Okay, so the proof actually isn't too hard, and it used to be an old homework question. Whether or not it's on this week's homework, I don't know. But it's not too hard. You just have to use Clairaut's theorem, okay, and literally like crank out the math. So do the curl, and then do the dot product or the dot product. Okay, and then with Clairaut's theorem, remember if you meet certain conditions, I'll let you look those up, then you can say that the second order partial derivatives are mixed partial derivatives are equal. Okay, and so just to wrap this video up, I have two vector fields here in 3 dimensions. I want you to determine the sign of the divergence for each. Okay, and so pause the video, try it out. I'll resume in just a moment. Okay, so maybe what we're thinking for this first one is, well, it seems like at any point that we pick, it's always expanding outward from or it's flowing out quicker than it's flowing in, so I'm thinking that this is positive. And then in the second case, if I look at any point in space and take a little ball in the space, it would seem that the flow in is greater than the flow out, so I'm thinking that this is negative. Okay, and so now here are the vector field equations, and so maybe we just want to compute this. Well, the divergence here is just 3, okay, and here, if you compute the divergence, okay, I'm going to say that there's a little bit of math that you have to do, but what you end up with is actually 0. So this vector field is incompressible. Okay, and so really what you would see at any point in space is that if we take a little ball, what we would see is that the flow in is the same as the flow out. Okay, so so we would say that in the second one, we would say that that vector field is incompressible when we look at the divergence. All right, so we have some more examples in the next video, and then I know you're just waiting for the last video where we have a theorem, so stay tuned for that too.